Hi, folks. Well, for some of you, this is the week you've been waiting for. This week, we get to talk about black holes and wormholes. And when I was in college a very long time ago, these things were still in the weird list. Like, yeah, we think they exist, but we weren't 100% sure about it. Now we even have pictures of black holes at the center of our very own galaxy. And they have gone from being totally theoretical and mathematically we think they exist to being, we believe, essential for the life of the universe as we know it. So let's take a little tour of what's going on this week. We're going to talk about what makes a black hole black or non-visible. And they are these big gravitational beasts that attract things gravitationally and emit no light. Of course, we have that study guide, that second instructor, which is your textbook to help us out. We're going to talk about properties of black holes, Schwarzschild radii, and general relativity. Also an invention, something discovered or unveiled about nature by Einstein. So we're going to talk a little bit about that. Those of you who like movies like Interstellar, we're going to talk about some of those things this week. Wormholes. Wormholes are theoretically possible. We're going to talk about what would one of those things look like? What advantages would they give us for traveling across the cosmos? Black holes are not all the same. Some of them can be very, very tiny. Those are hypothesized. Some are big because there's no such thing as just a black hole. They're the big beasts, or there are super duper gigantic black holes. So we're going to talk about different kinds of black holes. And then gamma ray bursts. Gamma ray bursts, these creatures that are born, I guess creatures is the wrong word, but these massive explosions of gamma rays, which are high energy electromagnetic rays that really announce the birth of a black hole. So lots of fun information this week. Of course, we have some constellations and our quiz, but let's talk about our lab. Now, to be quite frank, I could not come up with a really wonderful lab on black holes. It would be cool if I could have you make one in your bedroom, but you probably don't want one either because they're kind of wild and crazy things. So we're going to do a lab on a totally different topic, and that is parallax. We've talked about parallax a couple times back when we were talking about parsecs, and you're going to have to look back in your notes a little bit to talk about parallax and parsecs to look and read up on this a little bit. What I'm going to first ask you to do is watch this quick little YouTube video about how parallax is used to measure distances. It's just 2 minutes and does a really excellent job of how it is used in astronomy. Then I want you to go back and look at these definitions of parsec to really understand in your brain how these parallax arc seconds work, and answer some questions about what different motions are going to cause something to move through 1 parsec or 2 parsecs. And think about this carefully as you go through this. This might seem simple. It's kind of tricky. Then, do you really understand it? Answer these questions here and see if you really have got it. Now, this is going to be the general setup for the lab. So let's go to the photograph instead of that crazy diagram. What you're going to do from the edge of a tabletop is take a piece of tape. I've used blue painter's tape because it won't mar my table. And then with a centimeter ruler, I have marked different distances, and those are given to you in the data table. I have marked different distances on my piece of tape. Then you need something that will stand upright. If you happen to have a meter stick in your home, hallelujah, you can stand that on edge, but most people don't have that. So instead, take the edge of a cardboard box or the edge of a cereal box or something like that, and with a metric ruler, put a 0 on it, and then right to the right and to the left of it, 1 through 15 or 20 to the right and mark those little tick marks 1 centimeter away. And then to the other direction, put little tick marks every 1 centimeter, and then label enough of them so you know what centimeter is what. Then what you're going to do is this, and this is where it gets a little wacky. You have to be parallel. You have to be down on the same level as the table. So this is Mary's rendition of a nose and 2 eyeballs. So you're going to put your face right here. Your nose is going to go right here, and you're going to have your left eye and your right eye right there. And it works best if you can have someone to help you, but if no one is there to help you, so be it. You can do this alone. You're going to need something to stand a pin up in. I used an eraser out of my desk and a push pin. You can use whatever, a donut and a toothpick, whatever you got floating around. Place this at each one of these locations on the piece of tape, and these are distances from your nose. Okay, so put this in a position. And then here it says with your left eye open, so your left eye open, what you're going to read is where you see with your left eye open and your right eye is closed. This eye is closed, this one is open. What you're going to record is you're going to record which number back here you see the pin against. Then you pick this up, move it to a new location, and then without moving, you see where back here this is against. You pick this up, whoop, move it to a new location, and you see which number back here this is going to be against. And you're going to see the background numbers that this appears to be is going to change depending upon how close to your nose it is or how far away. I want you to get an understanding of this concept of parallax. So you're going to do this with your left eye open and then with your right eye open. If you happen to only have sight in one eye, please just write me a note and just only do it with one eye. And that will be just fine. Just please let me know so I don't wonder why you only did one. Then when you're done and you have your data, I want you to plot it on this graph. Please use the data from each eye and make it a different color and graph this. And hopefully you're going to see some interesting trends. Answer some questions about what you observe, and then some pretend people out here and what you think are going to happen. Then I want you to look at some stellar motion on an image here. I want you to measure the distance between this star and this star that has moved. Do a little converting, and this you can do this. This is not terribly hard, complicated math. And then you're going to calculate velocity, distance divided by time, using the distance up here and the motion numbers that we provide. And that's all there is to it. You're going to do a little division, and it is a very short lab this week. And the reason it's a very short lab is I keep working on coming up with a great black hole lab to add to it, but haven't got there yet. So you have a super duper week. Enjoy black holes. They're so fun and they're so weird. And yes, ask me lots of questions, because yeah, there's a lot of questions about black holes. So have a grand one, and we'll talk to you soon.